Good day, everyone. Today, we will discuss about scientific notation. So what is a scientific notation? Scientific notation is a system of notation used to express very large or very small numbers conveniently. A scientific notation is written in the form of a times 10 raised to n, where a is greater than or equal to 1 but less than 10, and n is an integer. Now, let us discuss the rule in writing large number in scientific notation. So, let us have example. The distance of the Earth from the Sun is approximately 93 million miles. So write this number in scientific notation, or write this distance in scientific notation. So let us discuss how are we going to write it in scientific notation. So the solution will be move the decimal point of the original number 93 million to the left until the first significant digit to the left of the decimal point, and copy the significant digits to its right. So we have here the 93 million. So from here, this is the decimal point of a whole number, location of the decimal point. So we will move the decimal point to the left. So we have here 1, 2, 3, 4, 5, 6, 7. So we will stop here, the new location of the decimal point, since the value of a must be greater than or equal to 1 but less than 10. So we will have 9.3. And then count the number of places you have moved the decimal point. So we have 7 places as we count the movement of the decimal point. And multiply 10 raised to that exponent. So the exponent is positive since we have here large number or whole number. So we have here 10 raised to 7. So we convert a large number to scientific notation. So therefore, 93 million is equal to 9.3 times 10 raised to 7. Now, let us have example or rules in writing small number in scientific notation. So let us have this problem. So write 0.0000000000734 in scientific notation. So we have a very small number. Okay, so how are we going to write it in scientific notation? So this will be our solution. So we move the decimal point of the original number to the right until the first significant digit to the left of the decimal point, and copy the significant digits to its right. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will stop here because we already have the first significant digit. So we will have 7.34. So count the number of places you have moved the decimal point. So we count it as 9 places and multiply 10 raised to the exponent. So the exponent is negative since we convert a small number to scientific notation. Or in other words, we convert a decimal number to scientific notation. So we will have this 10 raised to negative 9. So therefore, 0.00000000734 is equal to 7.34 times 10 raised to negative 9. Okay, let us have more example of writing large number or small number in scientific notation. But before that, let us recall that we are given this form when we are writing it in scientific notation. We have here a times 10 raised to n. So take note that if we are writing the value of a must be greater than or equal to 1 but less than 10, and n is any integer. Okay, let us have example number 1. So example number 1, we are going to write the following numbers in scientific notation. So 1, we have here 325,000. So these are the digits that we have given in this number 1. So we will form the value of A, that A must be greater than 1 but less than 10. So out of this number, we will have 3.25. Okay? And then we count the number of decimal places that we have moved until we have this decimal point. So if this is a whole number, this is the location of the decimal point. So we count 1, 2, 3, 4, 5. So this is the new location of the decimal point. So we have 5 places. So we will write it as the exponent of 10, wherein it is the value of n. So positive because we are converting large number or whole number in scientific notation. So this will be the answer. 3 and 2500 times 10 raised to 5. Now let us have the second example. So we are given here 0.00054. So this is a decimal number. So again, we will have the value of A, wherein A must be greater than 1 or equal to 1 but less than 10. So we will count or move the decimal point up to first digit, significant digit. So we have here 1, 2, 3, 4. So we have 5.4 times 10 raised to the value of n. So we count it 1, 2, 3, 4. So it must be 4, but since we are changing a small number or a decimal number in scientific notation, so the exponent of 10 must be negative. So we have here 5.4 times 10 raised to negative 4. Now let us have example number 3. So we are given 8,000. So we will change it to scientific notation. So we have to find the value of A. So we have here 8. This is the only number with greater than 0. So we have 8 here. So we will count the decimal point. So times 10 raised to 1, 2, 3. So we will stop here because this will be the new location of the decimal point. So we have moved the decimal point 3 places to the left. So this must be a whole number or a positive integer because we change a whole number to scientific notation. So the answer is 8 times 10 raised to 3. Now let us have example number 4. So example number 4, we are given 700 as our number. So how are we going to change it in scientific notation? So the value of A must be greater than or equal to 1 but less than 10. So we can use 7. So 7 times 10 raised to n. So our n will be the number of places as we move the decimal point. So this will be the location. We have here 1, 2. So it must be positive 2 because we changed whole number to scientific notation. So the answer will be 7 times 10 raised to 2. Now let us have example number 5. So we are given in number 5 as 0.000042. So take note that we have to get the value of A, which is greater than or equal to 1 but less than 10. So we have here 1, 2, 3, 4, 5. So we will stop here because this will be the first significant digit in our given number. So we will have 4.2 times 10 raised to n, wherein the value of n will be the number of decimal places movement to the right. So we have here 1, 2, 3, 4, 5. So this will be 5, but it is negative since we are changing a decimal number in scientific notation. So we have this answer, 4.2 times 10 raised to negative 5. Now let us have example number 6. So example number 6, we have here the number 75,200. So what will be the value of A here when we change it to scientific notation? So we have here 1, 2, 3, 4. So we will stop up to the second significant digit from the left. So we will have 7.52 times 10 raised to 4. Okay? So 4 will be positive since we are changing a whole number to scientific notation. So 75,200 in scientific notation is 7 and 5200 times 10 raised to 4. Now we have example number 7. And example number 7, we are given the number 3 million. Okay, so we will change it to scientific notation. So since we have here one significant digit from the right, or greater than 0, so we have here 3, and 3 is greater than 1 but less than 10. So we can use the value of A as 3 times 10 raised to, so let us count the decimal places, 1, 2, 3, 4, 5, 6. So this is in the location. So we have here 10 raised to 6. So positive because we are changing a whole number to scientific notation. So 3 million in scientific notation is 3 times 10 raised to 6. Now let us have example number 8. So 8, we are given here 2.75. So we will write it in scientific notation. So we have here 2.75. Since 2.75 is already the value of A, wherein A must be greater than or equal to 1 but less than 10. So we have here 2.75 times 10 raised to 0. So we use 0 because any number with a 0 exponent is always equal to 1. So when we multiply 1 to 2.75, still the answer is 2.75. So we follow the form of A times 10 raised to n. So we have the scientific notation, 2.75 times 10 raised to 0. Okay, now let us have example number 9. So we are given the number 0.0000062. So let us count the movement of the decimal point. So we have here 1, 2, 3, 4, 5, 6. So the movement is, or the decimal places is 6. And then we will stop here for the first significant digit. So we will have 6.2 times 10 raised to 1, 2, 3, 4, 5, 6. So negative 6. Negative because we are changing a decimal number to scientific notation. So we have this answer, 6.2 times 10 raised to negative 6. Now for the last example, we have here number 10. So we are given 75. So how are we going to change it in scientific notation? So take note that our value per A must be less than 10. So from this number, we get the value of A as 7.5. Then we just count the number of places, movement of the decimal point, so we just have 1. So times 10 raised to 1. So we have here 75 in scientific notation, 7 and 5 hundredths, or 5 tenths, sorry. 7 and 5 tenths times 10 raised to 1. Or we can write it as 7.5 times 10. Because 10 raised to 1 is the same with 10. So no need to write 1 as an exponent. We have here another example, but this time it is given in scientific notation. We will rewrite it in the original number or in decimal notation. So let us have example number 1. So we have here 3.2 times 10 raised to 7. So this is the first number that we are going to change in decimal notation. Since, take note that our exponent for the base 10 is positive, so it means that the movement of the decimal point is to the right. So we have here 3.2. So since this is positive, we move it 7 times or 7 places to the right. So we have here 1, 2, 3, 4, 5, 6, 7. So we already have this movement of the decimal point. So for those spaces that we don't have number, so we will just write 0. So we have here 3 zeros, 4, 5, 6. So this will be the number. We have here 32 million. Okay? So we are given the scientific notation 3.2 times 10 raised to 7. In decimal notation, we have 32 million. Okay, now let us have example number 2. So we are given 2.8 times 10 raised to negative 3. So we are given here number written in scientific notation. So take note that our exponent is negative 3. So since our exponent is negative 3, so the movement of the decimal point is to the left, or the movement of the decimal places is to the left. So we have here 2.8. So we move to the left 1, 2, 3. So again, we will add zeros. But since this is the new location of the decimal point, so we just write 0 in front of the last 0 digit. So we now have the answer 0.0028. So we have here the answer 28 10,000s. So 2.8 times 10 raised to negative 3 in decimal notation is 28 10,000s. Okay, let us have example number 3. So we are given here 5.2 times 10 raised to 2. Okay, so how are we going to rewrite it in decimal notation? So since we have here the exponent 2 positive, it means that the movement of the decimal point is to the right. So we have here 5.2, so 1, 2. So we will stop here because we already have 2 movement of the decimal point. So we just have to put 0 here. So the answer for 5 and 2/10 or 5.2 times 10 raised to 2 is 520. Now let us have example number 4. So example number 4, we are given 3.76 times 10 raised to negative 6. Okay, so here we have the exponent of 10 is negative 6. So it means that we will move the decimal point 6 times to the left. So we have here 3.76. So we move the decimal point 6 times to the left. So 1, 2, 3, 4, 5, 6. So this will be the new location of the decimal point. So we just have to put 0 here on the blank spaces. Okay, then we will just write 0 in front of the decimal point, left side. So the answer will be 0. We have 5 zeros, so 1, 2, 3, 4, 5. Then we have 3, 7, 6. So the answer for this scientific notation is 0.00000376. Now let us have example number 5. So in example number 5, we are given here 8.22 times 10. So since our value here is 10, so we don't see any number here for our exponent. So it means that the exponent is 1. So the exponent is 1. So it means that we will move the decimal point 1 place to the right. So we are given here 8.22. So we just move 1 place to the right. So we have here. So this will be the new location of the decimal point. So the answer is 82.2. Okay, let us have example number 6. We are given 2.35 times 10 raised to 4. So take note again that our exponent in our base 10 is 4 or positive 4. It means that the movement of the decimal point is 4 times to the right. So we have here 2.35. So we have 1, 2, 3, 4. So for the space that we don't have digits, so we will just put 0. So the answer will be 23,500. So this will be the location of the decimal point. So since it is a whole number, so no need to write the decimal point. So we have here 2.35 times 10 raised to 4 in decimal notation is 23,500. Now let us have example number 7. So we are given here 2.81 times 10 raised to negative 8. Since we are given the exponent for our base 10, which is negative 8, so it is negative, it means that the movement is 8 times to the left. So we are given here 2.81. So we have here 1, 2, 3, 4, 5, 6, 7, 8. So this will be the new location of the decimal point. So we just have to add 0 here. Okay, before the decimal point, and then put 0 on the spaces which are blank. So we have here 0. So how many zeros do we add? So 1, 2, 3, 4, 5, 6, 7. So 7 zeros. So we have here the final answer 0.0, 1, 2, 3, 4, 5, 6, 7. Then 2, 8, 1. So this will be the answer for example number 7. Now let us have example number 8. So for number 8, we are given 4.95 times 10 raised to 0. So take note again that we have an exponent which is 0. So we have 10 raised to 0. And again, any number with a 0 exponent is always equal to 1. So if the value of 10 raised to 0 is 1, so it means that we will have the same with 4.95 times 1. So the answer will be 4.95. So 4.95 times 10 raised to 0 is still 4.95. Now let us have example number 9. So we have here 6.32 times 10 raised to negative 2. So again, we have here the exponent of the base 10 which is negative 2. So it means that the decimal point will be moved 2 places to the left. So we have here 6.32. So we have 1, 2. So this will be the location of the decimal point. So we just have to put 0 here, 1, and then 1, 0 before the decimal point. So the answer will be 0.0632. Okay? So we have here the last example, number 10. Example, we are given here 4.17 times 10 raised to 7. So again, we will check the exponent of the base 10 here. So we have 7 positive. It means that we will move the decimal point 7 times to the right. So we have here 4.17. So we have 1, 2, 3, 4, 5, 6, 7. So we just add zeros here for the blank spaces. Okay, so we have 5 zeros. So the answer will be 41,700,000. So no need to put decimal point here because it's already a whole number. So final answer we have here for the 4.17 times 10 raised to 7 is 41,700,000.
Thank you for watching and God bless.